Alrighty. Hello, everybody. Good afternoon. My name is Jason Howe, and I'll be talking about port knocking. Given the name Knock Knock, let me in. I am the Red Team Chief with Kenny. I run Red Team, and we do a great job teaching blue teamers how to defend things, and have a lot of fun doing that. I'm a retired black teamer, and I was on black team for about 2 years, doing a lot of like infrastructure, networking, Linux, everything. I focus on Linux and networking, trying to dabble into Windows soon, probably this summer, maybe. And I'll be a penetration tester at SRA this coming summer. I was on call with them last summer. It was a good time. There's some fun pictures of me, Got Anthony and Malik and Mav, and that's Alex Noble being carried out of the cyber range conference room. Anyways, when we talk about port knocking, what it is, you guys the definition and then a metaphor, and then we'll show you how it works with a system D service called knockd that you can just sudo apt install, and then I'll show you another one called Vishnu that was written by a retired red teamer who goes by the name of Emmanuel. So let me know if you have any questions, and it should be very educational. So port knocking, a little example. So Alice and Bob are two favorite characters from every RITSEC story. They're running a secret operation to sell donuts. They have a secret location to make their donuts in a factory, and they've gotten threats from Big Donut, and so they want to secure their facilities. To keep it secure, they live inside the donut factory, and they created a secret knock pattern for their door, so that when one runs out to get ingredients, and they come back, they can knock on the door and they can communicate who it is. So if it's Big Donut, they don't open the door. So if the knock pattern matches, then they open the door. If it doesn't match, they don't open the door. And that right there is the essence of port knocking. If a pattern of packets matches what is expected, you do an action. If it's not, you don't do that action. Does that make sense? All right. So it's a persistence technique that works by listening for specific pattern of packets and executing an action. The attacker will send a specific pattern to closed ports, and when the pattern is matched, the specific action is executed. So, for example, if we knock on ports 7,000, 8,000, and 9,000, we will trigger opening port 22, which can then allow us to SSH into the box and do whatever we want. Does that make sense? Swag. So this is an official TTP on the Lighter Attack Framework. The number is T1205. They describe it as a technique where attackers will facilitate C2 communications. So they'll send a port knock, it'll open the port for the C2. The C2 will execute, and then they'll send another port knock to close the port, and it's a way to keep things stealthy and to not get caught. Another example of how this can be used is you'll send the port knock, and then it'll trigger reverse shell come back to you from your IP address, and that's the other common use case for port knocking. For non-malicious use cases, Eve has an awesome home lab setup, but she travels across the country for work, but they want to play a video game that they have set up on their home lab. So instead of keeping that the video game port open all the time, they set up a port knock to open up the video game port when they're away. So they send the port knock, it opens up the port, they can connect, play the video games, and then have a good time while they're traveling, staying in the hotel. And then once they're all done, they send a different port knock to close it up to keep it secure. So that's the non-malicious use cases and why it kind of exists. So that all make sense? Cool. So some malicious use cases. Since we're triggering a program to run, we can do anything with this. Anything that you can think of. So we can establish a reverse shell. We can disable the firewall. We can enable the user. We can turn off the service. Any action that you can take on the command line, you could do in a port knock. So it's a very useful tool because the port knocking service is going to listen below the firewall and will allow us to have remote code execution of having a shell on the box. So that's why this is a very powerful tactic. Everybody still with me? Alright, seeing nods around me, that's great. So knockd is a systemd is like an actual package that you can get on Linux. The man page is right there. And it's got two files really. The first one is etsy.conf, and this file is where you're going to configure all of the actions that you're going to take and the patterns you're going to listen for when you want to set your port knocking. So in this example, this is the default one that will be installed when you install knockd. It's going to set up the port knock sequence for enabling SSH. I think I can cut it off, but it'll also set up a closed SSH port knock, so that once you SSH into the box, all you need to do, you can close it up and just clean it up. Then the other file that you need is the Etsy default knockd file, and then it's over here. This one is you gotta configure like your interface to listen on over in that little options thing. There's a couple of other options that I didn't include here, but you can check them out in the man file. So, everybody with me so far? Wonderful. So, this is where it gets kind of fun, and this is how I use it on Red Team to deploy across a lot of boxes very easily. So, this on the right side is our Ansible playbook. If you don't know Ansible, there's plenty of talks out there, plenty of resources out there. I've given a couple talks, Brad's given a couple talks. So I'm not going to go over how Ansible works, but this is our playbook. The first thing we do is we install knockd. Then we copy over our config file, copy over our default file, and then we start the service. So where it gets fun in Ansible is these config files. If you see here, this is an Ansible.template, which means that I'm using a Jinja template to write the file and to do it in a variable way instead of hard coding everything and having to change them all the time. So in this file, this is our config file. Jinja templating is a fun language. It's built with Python and Ansible uses it a lot. So I have a set of a for loop here. I'm going to iterate over this commands object, which is a dictionary, and then the iterator is going to be the cmd. So I'm going to write the value of cmd to this bracket. I'm going to set these 4 attributes and these 4 strings in the thing, the values I set them in the dictionary. So you can see up here in this variables file that I have a dictionary called commands. Then the first object in the dictionary is OpenSSH. And then it's got 4 attributes that you can see over here. So basically what this is doing is going to iterate over that dictionary, write everything out so that it looks like this file, but these values are the ones that I want them to read. So this is pretty cool Ansible in my opinion, because if I want to change it up, all I have to do is add more objects up here, and then instead of having to change this file, I just change that and just build it up really nice. Everybody with me so far? Wonderful. This is do the same thing in the default file, except the only thing I'm really putting in here is the interface to listen on, which I set up in the top of the variables file. And this makes it very easy to customize the deploy for whatever competition I'm at or whatever host I gotta configure. So if you thought this was cool, look up Ansible and Jinja templating. Any questions? Alrighty, so we'll do a little demo. Alrighty, so there it is. So this is our Ansible playbook file right here. Same one that I just have it up on the screen. We have our template files right here, and then we have a variables file. So what I'm going to do is I'm going to deploy this on on what? On the top. Maybe. Okay. That is cool. Where'd my terminal go? Lost my terminal. Alrighty, so to run this Ansible, first thing I gotta do is connect to the VPN. Now that that's all set up, to explain this little thing right here, we call it Ansible playbook command. This is going to run our playbook. We're specifying in the tag guide, specify the inventory file to use. This inventory file configures all of our hosts that we're going to run our Ansible against. The tag T in our playbooks, we can configure tags for our plays. So when we run through things, we don't have to run everything. We just run the ones that we want. That's what the tag T flag does. There it is. So here's our play in our playbook. So the tag here is knockout, and that's what I call the Ansible. So we're just going to limit this to Team 14's host, their Ubuntu 1. And since our playbook is very restrictive, we don't need to use the tactile flag to limit anything. And away we go. So the first thing we're going to do is going to just check, make sure the host is up. And it should be. Come on, VPN. I tested yesterday like 10 minutes ago. Alright, so you can see that it's gathered. Well, so yeah, it's gathering facts, which is okay. The host is up, which is great. Then it's gonna install the service. It's gonna copy over the 2 config files, and it's gonna like restart it so that it runs. While that's happening, I'm gonna reestablish my SSH connections because they're broken. Alrighty, so this shows that our Ansible ran. It changed those files, or it changed something on the box. So that means that it was successful, and we can confirm this by just running a little ls on the etc nocd config file, and it's there. So that's great. So the other side of nocd is the knock client, which is just called knock. The way that works is just type knock, and we're going to go tag B for verbose, specify, actually let's put it in the man page real quick because I don't remember. So yep, this is the knock, this is the port knock client for it. So yeah, we got to specify the options, specify the host, and then the pattern. So in our Ansible, what we did was something. VS Code is not responding. It's back. Cool. So our sequence here is 7,000, 8,000, 9,000. By default, it's going to specify, it's going to use TCP, but we can also configure it to have a UDP pattern or both. If it doesn't really matter, you can very customizable. So for our command, we have a knock, which is specified on our client. Then we're using tag E for the verbose. Give it the IP address and then the pattern. Huh? Maybe it's supposed to be. There it is. Alrighty, so it worked. We ran successfully, so that's good. Now, since it's a bit finicky, I think you have to run it twice when you're first starting it up. When we do that, we come back over here and we see our message. We configured it that when it ran, it was going to echo out nocd is great. This is our terminal here. We have an echo message that nocd is great. So it worked, which is pretty nifty. The other thing that you can do to like debug this is you can tail the messages file. Well, actually, I think it's var log systemd. So in this file, it's the syslog. So we're just tailing it. We can see that knockd is running here, and it did a stage 1, stage 2, stage 3, and then it worked. So then I ran the command, and it's balling. So that's knockd, and that's how it works. And that's pretty cool in my opinion. You guys understand all that? Swag. So yeah, Vishnu is a port knocker. It's written in Go. It is written by the red team chief before me. His name is Emmanuel. Wonderful guy, working down in Nova now. In this, it says it's a custom tool. It has a custom callback port. You can specify the pattern of how you're going to do port knocking. But the feature this has, it gives you a reverse shell in the IP address that you are doing the port knocking from. So it works on Linux, FreeBSD, and Windows. And I'm going to go over the code, and then we'll do a demo with that too. So this is public on GitHub. This is what we got. You guys did that all right? Is that better? Alrighty. So this is this right here is where you define the pattern that you're gonna knock on, and then this is where you define your callback port. So it does all that. Then this is setting up a listener for the packets, and then goes from there. So in here, if it is running and you receive the knock pattern, it's going to give you the callback, like connect back shell is what he calls it in here. It needs to get the remote IP address from the packets, and it's printing out some stuff. So yeah, that's all it really is. One place where you listen for packets, and where you send it to your handler, and then how you do your connect back. So this is the code, very simple to use. You also, I'm sure you can include it in a make file, so you can just compile it real easy. Yep, there it is. So yeah, feel free to use it if you guys want to. Now we're gonna go back to RVM, which is so. All right. Alright, so the way that this one works is you have to listen on your connect back port, and then you have to send the knock pattern. So we're going to set up our listener on the right side. Just a little NC tag L. Callback port is 8080. So that is running. And then over here, there is a lovely Python file that uses escapee library to build the packet and send them out. So we specify our target IP address, specify the TCP port, like the packet pattern we want to use, and then we just loop over them and send the packets, and away we go. So to do this, and fun fact, to run escape you need to have sudo permissions, which I always forget. Hopefully that worked. Alright, so there's our output that the program worked, that it sent the packets. The fun thing with netcat is you don't get a prompt, but if it worked, you should get a response, which maybe it's not working. Alright, so since that didn't work, we're just going to rerun the Ansible to deploy the tool, and then it should work. So hang with me for a second. Ready. So we're going to stop that. We're going to do it again. And then we're going to rerun our port knocking script. And now if we run that, it works. So I'm not sure why it got uninstalled between last night and today, but it did. So we just run Ansible to deploy it, and it's there, it's running, it works. We got a shell, we got a root on the box. We got a little who am I root, which is wonderful. So those are 2 port knocking tools, and I hope you guys learned what port knocking is and how it works. So if you have any questions, I'll take them right now. Yes, Chase.
In like an actual integration test, how does like a port knock service on the server defend against someone just like buzzing them and just hitting them and force to kind of like see if something like
You probably wouldn't have it installed on the box in the first place. Otherwise, it would be you'd be able to detect it and then exploit it. So, everybody hear the question? Sure, great, cool. Any other questions? I will say, in like a pen testing environment, most of the time you're doing it against like corporate networks, and they're not going to have a port knocking thing set up. Since it's a persistence tactic, an attacker could set it up after they installed and got like their initial foothold, but you're most likely not going to see a like corporate environment have a port knocking tool there for benign reasons. Any other questions? Alrighty, thanks guys.